good news for today. We're talking about linear functions, which we already started talking about last week. So we looked at y equals mx plus b, pulling out the slope of m, and the b, the y-intercept. We looked at graphing lines. We're actually just going to continue that today. So we're still looking at working with equations and then using it to create models of like real-world scenarios and what that would look like. So linear functions. This is what we talked about last week. So remember that a linear function is often written in slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept, so where it crosses the y-axis. Now, this we can pull directly from the equation. It's our b, and that's the y-intercept. You'll notice that the x value of the y-intercept is 0. It goes nowhere left and right, it just goes up or down. There's also another intercept with linear equations, and that's where it crosses the x-axis. The y value would be 0 because it goes nowhere up or down. That's called the x-intercept. So we're going to start by looking at our x and y intercepts. So on a graph, it's pretty easy to see. You just look at where it crosses the axes. You can also pull it from an equation. And I'm going to show you like the math behind it, but we know how to pull the y-intercept directly from this equation. It's going to be 2. We need to put it in a point form if we're asked for the y-intercept, but really we know it's going to be 2. But I'm going to show you the mathematics behind it and then how we can present our answers. So if we're trying to find the x and y-intercept, we're going to take the equation and make x 0, and then we're going to take the equation and make y 0. So the first thing we're going to do is make x 0. If x equals 0, then y is equal to negative 3 times 0 plus 2. We're just going to calculate. Negative 3 times 0 is 0. 0 plus 2 is 2. Now, that we expected, our y-intercept, where x is 0, is 0, 2. And again, that number, that 2 at least, can be pulled directly from that equation. The x-intercept we're going to find by making y 0. So if we then take our equation, we're going to plug the 0 in where the y is. So 0 equals negative 3x plus 2. And then we're solving for x. So we're going to subtract 2 from both sides. So that would be negative 2 equals negative 3x. And then we would divide by negative 3. So negative divided by negative, positive, you would just say x equals 2/3. So our point then would be 2/3, 0. And that would be our x-intercept, where it crosses the x-axis. Any questions on that process? 0 in for x, 0 in for y, and then solve. All right, let's look at example 2. Notice this says g of x equals 1/2 x plus 3 instead of y equals. It means the same thing. It's a different notation, and I want you to get used to seeing different notations. So in this case, we still have an x, so we're going to make x 0. But then the way we would write this instead of y equals is we would say g of 0 equals 1/2 times 0 plus 3. So that's going to be 0 plus 3. Which is 3. And again, that's the number we expected because y equals mx plus 3. We can pull that straight out. Our point would be 0, 3. I want you to understand this process because if it's not in y equals mx plus b form, it's not going to be easy to just say, oh, the y-intercept is 3. You need to at least know you can plug 0 in. All right, so now we're going to make g of x equal to 0. So that means we have 0 equals 1/2 x plus 3. We'll subtract 3 from both sides. We'll get negative 3 equals 1/2 x. Does anyone remember how we get rid of that 1/2? What'd you say? Good job. Multiply by 2 over 1. So we're going to multiply the other side by 2 over 1 also. So we get negative 6 equals x. So that'd be negative 6, 0. Any questions about those two examples so far? All right, and let's look at example 3. So notice this is f of t. We don't have an x anymore. We have a t. We're going to do it the same way. It's just the name is different. So we're going to start by making t 0. So f of 0 is equal to negative 10 times 0 plus 2,800. That will be 0 plus 2,800, which equals 2,800. So our point would be 0, 2,800. And then we would make f of t 0. So 0 equals negative 10t plus 2,800. We'd subtract 2,800 from both sides. And we get negative 2,800 equals negative 10t. Divide both sides by negative 10 to get t equals positive 280. So our point would be 280, 0. Take a look at those 3 examples. Make sure you don't have any questions about how to pull out those intercepts. If you were in a situation where you needed to graph and that's all you had, you can plot the 2 intercepts and draw a line through them. Typically, we like to have 3 points to draw a line, but 2 works if you need it. Any questions? Okay, next section is just review of what we talked about last time. So if we're using slope-intercept form, pulling out the slope is really easy because y equals mx plus b is our goal, where m is our slope. Now, the important thing to note is that if someone were to change the order of this equation, so they did y equals b plus mx, that doesn't change what number the slope is. So your slope is always going to be the coefficient in front of the x, the number that's pushed right up against it. So in this first equation, what would our slope be? Yep, negative 12 or negative 12 over 1. All right, what about f of x equals x plus 4? What would our slope be? 1 over 1.
Do you have to write like over?
The only reason I encourage you to do it as a fraction when you're pulling it out is for graphing. You have to have a fraction, up and over, down and over. Really, it makes no difference, as long as you know that 12 is 12 over 1, 1 is 1 over 1. All right, next one, what would our slope be? Nice, negative 4 over 1, not 3. Even though 3 comes first, we've switched the order. You're going with the 1 pushed up against the x. And then the next one, what would that be? 1/2, good. Okay, any questions on finding slope? Good. Okay, so now we need to talk about finding slope when we don't have a nice equation written in y equals mx plus b form. So we're going to find the slope from 2 points. So these can be any 2 points on your line. And if you have more than 2 points, you can pick any 2 points on your line. They don't even have to be right next to each other on the line. Any 2 points on your line. Now, the equation is change in y over change in x. What that means is we do y minus y over x minus x. Now, you will see in the equation y2 minus y1 over x2 minus x1. The only reason it has that 1 and 2 in there is to point out to you that the x and y that are on top of each other have to come from the same point. So it doesn't really matter what point you start with. It doesn't matter which y you call y1 and which one you call y2. But the x and y on top of each other have to come from the same point. Okay? And then there is one other thing to note, and that's that the two x values can't be equal. And my question is, why can't the two x values be equal to each other? Yeah. Why can't you have 0 on the bottom?
That's a great question.
I know. Does anyone know why you can't have 0 on the bottom? Okay, well, Caitlin's, oh, yes. What kind of straight line? Yeah, you're right. All of those things that you said are great. Let's write our answer, and then I want to explain, because this, well, I'll explain that in a second. Okay, subtracting them would produce a 0 in the denominator, which is undefined. And there's a couple of reasons why I want to stress this, but I want to just explain it first. So you can think about this in a couple ways. You can think about it in terms of what the definition of a slope is. Okay, the definition of our slope is a gradual change in your, how would I describe this? We always say change y over change in x, rise over run. Incline, let's use that word. So a gradual change in your incline. It's easy to understand that when you're walking horizontally, okay, that you would have 0 change in your incline. If you've ever walked on a treadmill and you change the incline right, it lifts it up and down. So when you're walking straight, there's no change in your incline. Horizontal line has a slope of 0. It's also easy to understand that if you're walking up, your incline is increasing, you have a positive slope. When you're walking down, it's negative. When you have a vertical line, there is no incline. There is no run. It's going nowhere, left and right. So we can't do that work. The other way to think about it is with multiplication and division. And you don't need to write this down, but I just want you to process with me for a second. So if we know that 12 divided by 4 is 3, what that means mathematically is that multiplying the denominator by the quotient, so these two numbers, multiplying these should produce that. So if we were to have a 0 on the top of our fraction, 0 divided by 3 equals something, let's just call it x. In theory, that means that these two, when multiplied together, have to equal that. What would x have to be? 0. That's the only option to multiply and get 0. So 0 on the top of a fraction produces an answer of 0. When you put 0 on the bottom of a fraction, however, what we're saying is that these two multiplied together have to equal 3, which isn't mathematically possible. You can't multiply anything by 0 to end up with 3. So whenever we have 0 on the bottom of a fraction, we don't get an answer of 0. We have what's called an undefined answer. And we literally write the word undefined. The reason I feel like it's so important to mention this is because I go back to let's just say an elementary teacher that I have interacted with. About 20 years into her career is when I was helping one of her students, and they were doing division with fractions. And they got this answer, and they said, or they got this problem, and they said, oh, the answer's 0, and they got this problem, and they said, oh, the answer's 0, and I said, oh, no, let's check this one again, go back to your notes. And in the notes, it said the answer's 0. And I was like, you must have written that wrong. Upon investigating, what I found is that for the first 20 years of her career, she was teaching kids that division with 0 in any location of the fraction, the answer is 0. That is so mathematically wrong. But see, this is the problem. You don't go into, I would argue, that you don't go into elementary education typically because you love math. If you love math, typically you go into math education at a secondary level. Usually, when you go into elementary education, you love kids, or you love a self-contained classroom, or you love teaching. But most of the elementary teachers I have met don't go into it because they have a love of math. Because of that, we are seeing a huge need in our elementary educators to have a good foundation of math knowledge, which means you know that division by 0 is undefined, okay? So log that away. So when you are teaching your elementary students, you do not lead them astray for 20 years. Okay, so here we go. We are going to use our new formula to find the slope. So remember, we have an x, a y, an x, and a y. For our slope, we are going to put our 2 y's on top, and it does not matter which one you start with. I'm going to start with this 1. We are always subtracting, and then we're putting our second y, which is -3. Be careful with those double negatives. Now, here is where you have to be careful. It doesn't matter which y you start with, but whatever y you start with, you have to start with that x. So we started with 1, so we have to start with -1. We're always subtracting, and then our other one is -4. We're going to take care of any double negatives. So this would be 1 plus 3 and -1 plus 4. Are you all with me on that? 2 negatives make a positive. All right, 1 plus 3, 4. -1 plus 4, 3. You reduce fully, but I wouldn't put it into a mixed number because slope we're always looking at a vertical distance over a horizontal distance, so 4/3 is your answer. If you had started with -3, you would have had -3 minus 1, and you would have had -4 minus -1. So this would be -4 over -3, and the 2 negatives would cancel to make a positive 4/3. Same answer either way. I show you that because I want you to see it doesn't matter which one you start with, as long as the numbers that are on top of each other are in the same set of parentheses. Does that make sense? Okay, so let's look at the second example then. So we have an xy, an xy. Which y do you want to start with? +3 or -3? Sure. +3, we always subtract. Our other y is -3. Which x are we going to have to start with? -2, we always subtract, and we have 1. Then we take care of any double negatives. So 3 plus 3 will be on the top, and -2 minus 1 on the bottom. 3 plus 3 is 6. -2 minus 1 is -3. So that would reduce to -2, or you could write it as -2 over 1. All right. Third example, we have an x, y, x, y. The y's are the same, so it really doesn't matter which one we start with. -3, we always subtract, and the other one is -3. And because it really doesn't matter which y we started with, because they're both the same, we can start with any x. So 4 minus -1. We're going to take care of any double negatives. So -3 plus 3, 4 plus 1. We get 0 over 5, so what's our final answer? 0. All right, and x, y, x, y. Do you want to start with 3 or -1? Okay, -1, we always subtract, and then we have 3. What x do we have to start with? Doesn't really matter. They're the same. 4, we always subtract 4. So we get -4 over 0. What's our answer? Good. Undefined. Any questions on finding slope when you only have 2 points to work with? Subtracting y's on top, x's on bottom. Okay. So now we're going to look at using that information. So we're going to start by looking at just like general situations or writing equations, and then we're going to get into our models, both of which are going to require you to use this and your y equals mx plus b. So in this case, we're going to graph the line that passes through -2, 4 and has a slope of -3/4. This will be pretty straightforward. We start with our point that's on the line. So -2, +4. And our slope is what tells us how to move from one point to the next point. So if we know that m is equal to -3 over 4, this is going to tell us down 3. And remember, we are always going right for our slope. So the negative tells us down, but we're always moving right. So we will go down 3 and right 4, and that's where we'll put another point. Our goal is always to get 3 points on if we can. In this case, you'll see that we would actually end up like off the graph a bit. But we are going to draw our line through those 3 points and draw arrows on the ends since it keeps going. Any questions on that? All right. So now we have to find the equation. We are told that it passes through this point and has a slope of -1. So first of all, equation, typically we're using y equals mx plus b. There are other equations. There's a point slope form as opposed to like a slope intercept form. I don't find them quite as useful. And this is the one you will always start with. So when it comes to elementary, if you're teaching any upper L or middle school, this is likely the one you're going to be teaching. So our equation, if we're going to write an equation, you have to fill in a number for m and a number for b, but you leave the variables x and y in the equation. That's our goal when we write an equation. Right now we know the slope, so that's our m, but we don't know the b. We do, however, know one example of x and y. So what we're going to do is we're going to use x, y, and m to find b. So we're going to plug in 4 for y, -1 for m, 2 for x, and we're going to solve this equation for b. So we have 4 equals negative 2 plus b. How would I get b by itself? Good. Add 2 to both sides. So 6 equals b. Now you need to give me your final equation. So that would be y equals negative 1x plus 6. Or you could just write negative x plus 6. Any questions on how we did that? All right. So then we'll take it one step further. All right, so this time we're given 2 points. If we're told to graph it, great, we can do that. If we're told to find slope, great. In this case, we're told to find the equation, so we're actually going to have to do a little bit of an involved process. So we're going to start by finding slope. We have xy, xy. Which y would you like to start with, negative 2 or positive 8? Positive 8. All right. 8, we are always subtracting, and our other number is negative 2. What x do we have to start with? 8. We are always subtracting, and our other number is negative 7. Then I'm going to get rid of my double negatives, so I'll have 8 plus 2 over 8 plus 7. That gives us 10 over 15. Can that be reduced? By what? Yep. And that would give us a final answer of 2 over 3, 2/3. So that's our m. Okay, but we've been asked to write an equation. So now we're going to use our m and one of our xy's to find our b. It does not matter which one you choose, so I would choose the one that's going to be the easiest to work with. So we have y equals mx plus b. I'm going to choose the positives because I feel like those are easier to work with. 8 equals 2/3 times 8 plus b. Now remember, when we're multiplying fractions, we're going straight across top, straight across bottom. So I'm going to make this 8 over 1 so that I can do that. So I have 8 equals 16/3 plus b. How would I get b by itself? Good. Subtract 16 over 3 from both sides. Whoops. I'm going to go ahead and do this off to the side. So 8 over 1 minus 16 over 3. What do I need to subtract fractions? Yep. So I'm going to make a denominator of 3 by multiplying top and bottom by 3. So I have 24 over 3 minus 16 over 3. What would that give me? 8/3. So b is equal to 8/3. So when I go to write my final equation, I'll have y equals 2/3 x plus 8/3. Your answers will not always look pretty, but that's okay, as long as they're fully reduced. Any questions on that piece? All right. So then let's look at models, finding linear models. So we have 4 examples we're going to work through. I think the most challenging part is figuring out where to put which numbers. So suppose that a car burns 0.04 gallons of gas per mile driven. I'm going to highlight and circle and whatever I need to this word right here, per. That word, when you see it, is going to indicate your times x, your mx in the equation. your slope, if you want to think about it that way. So that word per indicates your mx in the equation. Okay, so suppose that a car burns 0.0 gallons of gas per mile driven, and the fuel tank, which holds 18 gallons of gas, is full. Find a linear model for the amount of fuel remaining in the gas tank after driving X miles. That's your other clue right there. They're telling you that X represents miles. Then use your model to determine the number of miles the car can be driven before running out of gas. So let's just review something really quick. So with our y equals mx plus b, typically speaking, in a real world scenario, the y is some sort of total. In this case, it's going to be gallons of gas, but some sort of total. The b is going to be some sort of starting amount or original amount. And then this part in the middle here is your amount per. Okay, so as we're setting up our equation here, we don't know, well, let's start here. It's important to note what our variables are going to represent. And we don't have to always use X and Y. If they say X miles, then I would use X. I typically always use XY. If they told you to use T, we would use T. But otherwise, it's really up to you. You could make it a letter that represents what it is demonstrating here. However, we are told that X is referring to miles. We have it here, but we also have it here. Because it says per mile, that's going to indicate that this is going to be the M, and this is going to be the X. So X is going to be the miles. The other quantity that we're working with here is gallons of gas. So it says find a linear model for the amount of fuel remaining in the gas tank after driving X miles. So this will be the amount of fuel. Okay, so we're going to have y equals. My only question here is this 0.04. This is going to be our m because it's our amount per mile. Is that going to be positive or negative, and why? Raise your hand if you think it's going to be positive. Raise your hand if you think it's going to be negative. Raise your hand if you didn't vote. Okay, it's going to be negative. Does anyone know why? Kaylee? Yeah, it's burning. You're using gas. It's going away. Okay? So we have negative 0.04x plus. What was our starting amount? 18. The tank is full. It holds 18 and it is full. Okay, so this is part one of our problem. We wrote an equation. Now we are supposed to use the model to determine the number of miles the car can be driven before running out of gas. If I'm looking for miles, what letter am I looking for? X. So that means I have to plug something in for Y. Any ideas? Yeah? Y. Yeah. Exactly. It's the amount of fuel, and when you run out, there's 0 left. So we're going to plug 0 in for Y. And then we're going to solve for X. So we'll subtract 18 from both sides. So we have negative 18 equals negative 0.04x. We're going to divide both sides by negative 0.04. And we end up with x equals 450 equals x. Typically with these problems, you want to put it back into the context, so we're going to write a conclusion. You want to make sure you use units. So then use your model to determine the number of miles the car can be driven before running out of gas. We would say the car can be driven 450 miles. Any questions on that one? All right. Number 2. Suppose a 20-gallon gas tank contains 2 gallons of gas when a motorist decides to fill the tank. If the gas pump fills the tank at a rate of 0.1 gallons per second. That tells us right away mx. M is going to be 0.1. We still have to figure out if that's positive or negative. X is going to represent seconds if we choose to use the letter x. Find a linear function that models the amount of fuel in the tank t seconds. So they want us to use t, not x, after fueling begins. Then use your model to determine how long it will take for the motorist to fill the tank completely. So if we're going to say t represents seconds, what letter do you want to use for the other one? The amount of fuel. F. F will be the amount of fuel. All right, so we have F equals, now we've already spotted our mx, right, our 0.1 gallons per second. That 0.1, is it going to be positive or negative? Why positive? You're filling, you're increasing, it's going up. So 0.1 t, and what are we starting with? 2. Good. 2. Okay, so that's our model. That's part 1 of the problem. Part 2, then use your model to determine how long it will take for the motorist to fill the tank completely. If I'm looking for how long it will take, what letter am I searching for? T. So what am I going to fill in for F? Good, 20. Question. How do I know if I want to plug in 20 or 18? Who said that? Yeah. Our total is what we're putting in for F. So total is 20. Doesn't matter that we're starting with 2. We are already accounting for the fact that we're starting with 2 by adding 2. And actually, you'll see our first step is going to be to get it down to 18. So 20 equals 0.1 t plus 2. So now we're going to account for that 2. We're going to subtract it out. And we have 18 equals 0.1 t. We'll divide both sides by 0.1. And we get 180 equals t. So we would say it will take 180 seconds to fill the tank. What if I asked for it in minutes? Annika? 3 minutes. Yep, we would divide by 60. Any questions on example 2? All right. Example 3. The boiling point of water at sea level is 100 degrees Celsius. The boiling point decreases, that's our code word there, 3.5 centimeters per 1 kilometer increase in altitude. There's that per word again. So this is telling us our mx. Our slope is going to be 3.5. Our x, or whatever letter we end up using, is going to represent 1 kilometer increase in altitude. That's really what we're looking at, is the altitude, but the increase in altitude. So we're not saying it's at an altitude of 12,000. We're looking at how much did the altitude increase and putting that number in. Find a linear function that gives the boiling point of water as a function of altitude. So if we say that x is representing the increase in altitude, then y, we're trying to find a linear function that gives the boiling point of water. That's our y. Okay, so we're going to start with our y equals. We already know we're going to use 3.5. Is it going to be positive or negative? Negative, because it says decreases. So 3.5x, and where are we starting from? 100. So plus 100. This is our model. Now, in both previous examples, it said, then use your model to calculate. This one doesn't say that. Just find the model. So you're done. Okay, don't get too excited, though, because the last one's the most challenging. Okay. So, last example. A manufacturer, it's kind of challenging because I make you show your work. Some of you will be able to look at it and then figure out the answer in your head, but we're not going to do that because you have to know the math behind it. So, a manufacturer of economy cars has determined that 50,000 cars per month can be sold at a price of $18,000 per car. Okay, we have that piece of information. Then we're told a second piece of information. At a price of $17,500, the number of cars sold per month would increase to 55,000. We are then asked to determine a linear function that predicts the number of cars that will be sold at a price of X dollars. Okay, notice this X dollars here. That is telling us what X is going to be equal to. X is representing the money. Then use this model to predict the number of cars that will be sold at a price of 17,000. So Y is representing the number of cars. Okay. First thing we need to do is write a model. The problem is we are not given a starting amount. We are also not given an amount per, or a changing amount. So we are going to use our slope from 2 points formula by setting up two x, y points. Now, if x represents money, that means the money is going to come first in our ordered pair. So our first piece of information, $18,000, 50,000 cars. So 18,000, comma, 50,000. So I'm setting up an ordered pair with each individual unique situation. So my next one, 17,500 is the dollar amount, so that's my X. 55,000 is my Y. Okay. Now we are going to use our slope from 2 points formula. So we have an X, Y, y. Which y would you like to start with? 50,000 or 55,000? 55,000, good choice. 55,000, we are always starting with I'm out of room. We are always starting with subtraction, and then we're doing the other y. So 55,000 minus 50,000. Which x do we have to start with? Yep, 17,500 minus 18,000. All right, so then we're just subtracting on the top and the bottom. So we will have 5,000 divided by negative 500. When we do that math, we get negative 10. Question, does it make sense that our slope would be decreasing? Because that's what negative would mean. And if so, why would it make sense that our slope would be decreasing? Yeah, Maddie.
The amount of money is decreasing, and that's what the slope is.
Good. Good. The amount of money is what's decreasing. Okay, so we have our M, but we still need our B. So we are going to do our y equals mx plus b, and we're going to plug in one of our xy pairs with our slope. Do you have a preference? Do you want to do 18,000, 50,000, or 17,500, 55,000? Good choice. All right, so we're going to do 50,000, that's our y, equals negative 10 times 18,000, that's our x, plus b. We're going to do that multiplication, so 50,000 equals negative 180,000 plus b. And then we're going to add 180,000 to both sides. And we get b equals 230,000. Okay, so we have part one of our answer. Part one, y equals negative 10x plus 230,000. That right there is our linear function or linear model. It has an m and a b. But we have a part two. So it says, then use this model to predict the number of cars that will be sold at a price of 17,000. So we're going to take that equation of y equals negative 10x plus 230,000, and we are going to replace the x with 17,000. So we will have negative 170,000 plus 230,000. And that will give me an answer of 60,000. So we will say there will be 60,000 cars sold.
Will there be a problem like this on the test?
Probably. Yeah. Not a lot of them.
Okay, that's okay.
Well, I'll think. I don't know. We'll see. Okay, questions on how we got that? Okay. Does anyone need me to go back to the previous slide? Okay. All right, so that assignment on the bottom, 20 questions, 10.2, 10.3. That's your homework. You are going to get an email from me either tonight or tomorrow with a review sheet. The review sheet is optional, but it will be good practice for your tests because the format will be the same, the types of problems will be the same. And we'll go over it on Thursday if you have any questions. We actually are done early, you're welcome to stay and work on your assignment, or you're welcome to leave, except first you have to do an exit slip for me. So, today we did a, yes ma'am. Oh, yeah. Oh, okay. No, that's okay. You can. So we have done a lot today on calculating the slope of 2 points, or I mean the slope from 2 points, okay? So you're going to put your notes away, and I'm going to give you a little slip of paper. I'm going to put 2 points on the board. And you're going to see, can I calculate the slope from those 2 points? And then we're going to use these same bins again. You got to write your name on your paper. Same bins again. So you're going to put your paper, and you can do it upside down if you like, in the appropriate bins. So number 1, I'm confused. I need some clarification. Number 2, I almost have it. Almost have it, but I may need a little bit more practice. 3, I totally understand, and I can teach my peers.
Is that just for that concept or like the whole lesson?
Just this concept. Good question. Okay, so I have little slips of paper for you. Caitlin, will you hand this out for me? Thank you. And put your name on it, and I will put 2 problems up on the 2 points up on the screen. All right.
Okay, so yeah. So just say, what is it? Like I was just
Yeah. Just M. There's your 2 points. Try to find M. And when you're done, you can place your paper in the bin, and you can leave or you can stay.